My dear people, how are you? This is Dr. Venkat. Well, during our session today, we were unable to spend a lot of time on solving this problem. So, what I have done is that I have created this small video for you in which I'm going to solve this problem step by step. And the advantage is that you can pause the video whenever you want and take notes if you would like to, and then come back to the video. Yeah, shall we start it? Let us see what we have. We know that there is a 2-meter copper rod that is being heated from 20 to 90 degrees Celsius. The thermal coefficient of copper is given, and they want us to calculate the change in length. This is a very simple problem. Okay, now let us write down all the things that we know first. So we know that the initial length is 2 meter. Let us write that down. So L1 is 2 meter. And then we know that the initial temperature T1 is 20 and T2 is 90 degrees Celsius. So let us write that down as well. And then we know that the alpha, the thermal coefficient of copper, is 16 times 10 power negative 6 per degree Celsius. Let us write that down as well. Fantastic. Now, what do they want us to calculate? They want us to calculate the change in length delta L. So let us write that down. To find it is delta L. What is the formula for the change in length? If you want to pause the video, you can, and then write it down on your own. Okay, the formula for change in length, if you remember from the session, is alpha times L1 times the change in temperature. Look at it. We already know the value for alpha. We know the value for L1, T2 and T1. Fantastic. Now all that we have to do is to substitute the values. So let us substitute. If I substitute the values, this is what I get. Now some of you might want to pause the video and try to put it in your scientific calculator and see if you get the result, because some of you might struggle with scientific calculators initially. Yeah, okay. So when I put it in my calculator, I get the value 0.00224 meter. Otherwise it is 2.24 millimeter. So all that we are saying is this particular copper rod, when it's being heated, the change in length is 2.24 millimeter. That's it. Do you see how simple this problem is? Huh? Fantastic. Now, I have an additional question for you. Okay. My question is, yeah, what temperature should a rod of 2 meter of titanium should be heated for it to have 2.24 millimeter change in length? This is a challenge for you. Try to work it out.